Alright, well, welcome to the Nature of Light Part 2. So in the last video we looked at the relationship between wavelength and frequency and how light acts in waveform. Well, light can also act like a particle, and we can measure the energy that the light has when it's acting like a particle. So we have to use, obviously, a different equation when we're looking at light in this way. So the equation we're going to use is E equals h nu. So we know what nu is. Nu is still frequency measured in hertz, which we saw in the last video is also 1 over s because it's how many cycles in 1 second, or it can also be denoted as s to the negative 1. H is nu. That's actually going to be Planck's constant. So this is a constant, doesn't change, named after a scientist, and it's equal to 6.626 times 10 to the negative 34th joules per second. So a joule is just a unit of energy, which is what my E stands for. Energy measured in joules. Again, another scientist that we named this one after, and it's represented by an uppercase J. So let's look at how we're going to use this information with a practice problem. So what is the energy of a gamma ray with a frequency of 2 times 10 to the 22nd hertz? Well, since we're finding E, that's easy because it's just E equals H, which is our Planck's constant, so 6.626 times 10 to the negative 34 joules per second times my frequency, which is 2 times 10 to the 22nd hertz, but I know that's 1 over s. So I'm going to use that so I can cancel some of my units. So I do my multiplication. My seconds are going to cancel out. And what I'm left with is E equals 1.35 times 10 to the negative 11th joules is my energy. Now what if I had an equation like this? What is the energy of light with a wavelength of 700 nanometers? So I need to find energy, but when I look up at this equation, energy I can only figure out energy using this equation, or it's the only equation that we're familiar with to solve for energy. It only uses frequency and Planck's constant, but I've been given wavelength. So how can I solve this problem? Well, I can't solve it given just the information here, so what I actually have to do is go back to what we learned in the last video, C equals lambda nu, and using this equation, since I have wavelength, I can solve for frequency, and then I can solve for energy. So let's see how we would solve this question. So first of all, my 700 nanometers, I know that the speed of light is in meters, so I'm going to have to change that first. So 700 nanometers equals nanometers on the bottom, meters on the top. 1 meter equals 10 to the 9th nanometers, which equals 7 times 10 to the negative 7th meters. Now I can plug everything in for C. So I know that my speed of light is 2.998 times 10 to the 8th meters per second. And again, I'm using this equation so that I can use my wavelength to find my nu, excuse me. So C equals my speed of light equals my wavelength, which is 7 times 10 to the negative 7th meters times nu, which is what I'm solving for. Now I can divide. My meters are going to cancel, and my frequency is going to be equal to 4.3 times 10 to the 14th hertz. So now that I have my frequency, I can find my energy. Let's see if I can make some of this a little smaller, get it out of the way. So here's my frequency. Then I'm going to use, let's pick a different color. So now using my energy equation, E equals Planck's constant, 6.626 times 10 to the negative 34th joules per second times nu, which is 4.3 times 10 to the 14th. And so that my units are constant, I'm going to use 1 over s. So when I multiply, my seconds are going to cancel. And I'm going to get an energy equal to 2.85 times 10 to the negative 19th joules. Okay, so just be aware that sometimes you might have to use these two equations in combination with each other, but we'll always give you Planck's constant and we'll always give you C, the 2.998 times 10 to the 8th meters per second. The only thing you're going to have to be aware of, are you using, which equation are you using? Do you need to use them together, and do you need to convert from nanometers to meters to make sure your units all agree? All right, for homework, yes, you do have homework. You need to complete the Chapter 5 review worksheet. All of it, please. For Monday, you should have plenty of time left in class, hopefully, if you worked efficiently, to get started on it and perhaps get most of it done. Otherwise, have a happy Halloween. Be safe out there and have a great weekend, and I will see you on Monday.